Forging is one of the oldest metalworking processes in human history. But SMS Group has taken it to a level ancient blacksmiths could never have imagined. When metal is forged, it's heated to extreme temperatures and shaped under massive compressive force, realigning the metal's internal grain structure and making the final product significantly stronger than cast or machined parts. SMS Group's plants harness this at an industrial scale, with equipment operating at thousands of tons of force and temperatures exceeding 2,000 degrees Fahrenheit. Extrusion is one of the most important manufacturing processes in modern industry, producing continuous, consistent profiles at high speed with minimal waste. Without it, the window frames surrounding you right now would be far more expensive to make. Here, Aluplast GmbH is extruding a PVC window profile. Molten PVC exits the die at the tool head, already holding its precise cross-sectional shape. It then moves through calibration, where the dimensions are locked in, followed by a cooling section that solidifies the profile completely. A takeoff unit pulls it forward at a controlled, steady speed before it reaches the finishing stage, where it is cut to length and ready for installation. Extrusion doesn't just build window frames, it also puts rubber on the road. In tire production, the rubber compound is heated, calendared, then forced through extruder machines into continuous sheets, cooled and cut to length. A coating machine wraps nylon, steel, and polyester in rubber, placed beneath the tread for strength. Steel wires form the bead core, eliminating vibrations at speed. Everything converges on a tire builder drum, pressed in a mold for 2 hours and rigorously tested before leaving the factory. Bending thick steel tubes by hand is back-breaking work, and the results are rarely precise. That's where the hydraulic tube bender comes in. This machine shapes handrails, race car chassis, roll cages, and more with a level of accuracy no human arm could match. There's no physical effort involved. Position the tube, and the machine does the rest. Faster than manual models, more affordable than fully programmable alternatives, it's the kind of tool that makes you wonder how fabrication shops ever managed without it. Steel parts take a beating in industrial environments, and burnt carbon buildup is one of the most stubborn contaminants to deal with. Chemical treatments are slow. Ultrasonic cleaning gets the job done, but not without its limitations. P-Laser had a better idea. Their laser cleaning technology strips burnt carbon from steel surfaces in a single pass, with zero contact, zero chemicals, and zero damage to the metal beneath. What once took hours now takes minutes, and the results speak for themselves. It's the kind of industrial solution that doesn't just save time and money, it makes every alternative look obsolete. Here, two axles are being welded onto a single component simultaneously using rotary friction welding. Unlike conventional welding, there's no flame or filler material involved. Instead, one piece of metal is spun at high speed and forced against a stationary component. The rotation generates intense friction at the contact point, producing enough heat to fuse both pieces into one solid, seamless joint, all in a matter of seconds. Once bonded, the excess material pushed out at the joint is sheared clean off, leaving a precise, clean finish ready for the next stage. Tojiro has been crafting world-class knives in Japan for over 50 years, and the process is as precise as the cut each blade delivers. Blades are made from premium steel including VG10 and DP cobalt alloy, chosen for hardness, sharpness, and long-term edge retention. For high-volume production, Tojiro uses a press-out method combining modern automation with traditional techniques. Custom orders, however, are hand-forged by skilled craftsmen using techniques inherited directly from Japanese swordsmiths. Welding the blade to the handle is given particular priority, and every knife is labeled by hand, a small but telling sign of the craftsmanship behind each piece. The Hausler VRM is a universal roller bending machine, and what it's about to do to this metal sheet is nothing short of remarkable. It's applying 600 tons of force to bend a sheet of steel, measuring 98 feet long and 10 feet wide, into a perfect cylinder. Upper and lower hydraulic supports work in tandem to precisely control the diameter of the ring. No guesswork, just pure mechanical precision. Once formed, a skilled welder seals the seam by hand. The finished rings go on to become critical components in some of the largest industrial equipment on the planet. Raw steel in, perfect cylinder out. The piston PE spiropipe is a two-layered corrugated pipe, and its construction is smarter than it looks. Both layers are made from high-density polyethylene. The inner wall is smooth and continuously extruded, while the outer layer is a spiral wound corrugated profile reinforced with HDPE-coated hose. That corrugated outer layer isn't just for looks. Those smaller ribs dramatically increase the pipe's structural strength without adding unnecessary weight. The result is a pipe that can be manufactured across a wide range of stiffness classes, making it adaptable to virtually any underground or drainage application. Simple materials, intelligent design, serious performance. CNC machining has transformed modern manufacturing, and Klingelnberg is pushing it to its absolute limits. Inside their factory, massive CNC machines produce large spiral bevel gears with extraordinary precision, handling every grinding and turning operation with computer-controlled accuracy. At the center of it all is the Klingelnberg C300, the world's largest face-hobbing machine, engineered specifically for consistent, reliable cutting at a scale most machines simply can't match. But technology alone isn't enough. After every single process, metallurgical experts run rigorous physical tests on each unit, because at this level of engineering, there's no room for error. Precision by machine, verified by expertise. Friction welding generates heat through force, and this close-up shows exactly what that looks like. As the two metals are pressed together, molten material gets pushed outward, forming a glowing double ring of red-hot excess around the joint. That ring isn't just a byproduct, it's a built-in visual indicator telling the operator the bond is complete. Once cooled, the joint is cleaner and stronger than anything a traditional welding torch could achieve. Before carbon fiber becomes the lightweight, high-strength material used in aerospace, motorsport, and defense, it has to be woven. And that's exactly what a braiding machine does. By interlacing 3 or more strands of yarn or wire simultaneously, These machines produce everything from rope and reinforced hose to power cords and industrial lace. The MOT 96-1-130 takes that concept into high-performance territory, designed specifically for braiding carbon fiber. With 96 carriers on the head, it can braid mandrels ranging from 20 by 20 to 39 inches, making it versatile enough for a wide range of composite manufacturing applications. Most people don't think twice about throwing out an old mattress. But here's something worth knowing. 90% of it can be fully recycled. At the Retus recycling facility, hundreds of mattresses arrive every single day. The process starts with detecting and removing all metal components, followed by stripping the covers. What's left, the foam, gets cut into blocks, then shredded into small pieces ready for chemical recycling. Chemical recycling breaks polyurethane foam back down into its original raw materials. Through a process called glycolysis, polyol is extracted from the foam and used to manufacture brand new foam products. What looked like trash just became a raw material all over again. Iron is the backbone of modern manufacturing, and for good reason. It's one of the strongest materials on Earth and the fourth most abundant element in the Earth's crust. What you're watching here is ring rolling, a precision metal forming technique that shapes heated iron into perfect cylindrical rings. A glass room operator monitors every piece throughout the process, ensuring each molded unit meets exact dimensional requirements. Ring rolling is now the go-to method for producing seamless bearing rings, hubs, flanges, thin wall cylinders, and countless other critical components, delivering consistent strength and precision that traditional machining simply can't match.